Hey everybody, thank you for tuning in to this tutorial video. This is going to cover solving systems of equations by elimination, which is something you've already learned about, but I'm going to try to address some of the questions that you might still have. Okay, so just as a quick review, we know that a system consists of two or more equations, which we usually label as equation 1 and equation 2 in our steps to make sure that we all stay on the same page. So it's two equations with two different variables, usually x and y. So when you solve a system, essentially it's just solving two equations for the two variables. You've got to find the value of x and the value of y that will make both equations true. And the elimination method is sort of like a three-step process, or at least that's how we broke down the guidelines for you to follow so that you can carry through this process. Okay, so just as a quick review. When you're going to solve a system, of course you want to label everything first. The first step is to find a zero pair, okay? Because when you find a zero pair, it allows you to eliminate one of your variables, and that's why this is called the elimination method, okay? By eliminating one of the variables, you're able to add the remaining parts of the two equations and solve for one of the variables, okay? And once you know the value of one of the variables, you can then use that to plug it in to one of your original equations and solve for the other variable that you still don't know, okay? So again, these are just general guidelines that you can follow for solving a system by elimination. And these are the essential questions that I really want to get at in this video. Which is something that a lot of students always ask about when we teach this method. So many students often ask, in relation to step 1 and 2, when you're basically creating the zero pair, does it matter where you start? Does it matter if you eliminate x or you eliminate y first? Okay, so this is the first thing I want to answer for you. The second thing, which is kind of related, is once you're in step 3 where you have to plug back in, does it matter which of the two original equations you plug into? Okay, and your teacher might have already addressed this, so if you feel like you have a good understanding of this, then you don't definitely need to watch this video, but it definitely wouldn't hurt. Okay, so here we go. Here's my system of equations. Again, remember to always label them equation 1, equation 2. And here on the right, I've already summarized the steps again. So I'm going to go ahead and start solving. And before I get ahead of myself, the first thing I always do is copy the problem again, clean and neat, so that I don't mess with the original question. Because sometimes when you start writing on it or messing with it, it's really hard to see what it was originally. So I always like to leave the original alone and just copy it. 8x plus y equals negative 16. Negative 3x plus y equals negative 5. All right, so I just copy it so that I can start out doing all my writing here. All right, so as I inspect this system of equations, I always have a choice. I can either choose to eliminate x or I can choose to eliminate y. So step 1 is find the zero pair. So is there a zero pair already available? And in this case, no, because neither of my variables have the same coefficient with opposite signs. So I can't cancel anything out. If I consider that x, 8 times nothing will give me 3, and 3 times nothing will give me 8. So just by kind of inspecting this, I know that x is probably not the way to go. If I look at y, the coefficient, as we know, since there's no coefficient there, they both have a coefficient of 1. Okay, so at the very least, it already has the same number. Now my job is to just make them the opposite sign so that they can actually cancel out. And we know that the best way, or one of the easiest ways to switch the sign on something, is to simply multiply times the negative 1. All right, so that's what I'm going to do. And of course, here you have a choice. You can either make the first equation multiply times -1, or you can make the second equation. It really doesn't matter. But just for the sake of simplicity, I'm going to multiply the first equation times a -1. And let me not forget to label them. Equation 1, equation 2. I'm also going to label, this is basically me doing step 1 in my guidelines. I'm creating my zero pair, so I can cancel something out. All right, so my first equation, when I multiply everything times -1, that's going to become -8x minus y equals positive 16, because the negative times the negative, of course, is a positive. The second equation, I left that alone because I wanted that one to stay positive 1y. So that I'm just going to bring it down. Negative 3x plus y equals -5. Okay, so notice that now I have a zero pair with -y and positive y. So I can cancel that out. So that allows me to move on to step 2, where I add the two equations. When I add the two equations, -y plus positive y cancels out. So that's my zero pair. And then I just have to add the rest of the equation. So -8x and -3x gives me -11x. That's gone. Equals. Almost made a boo-boo here. This would have been really silly of me, but notice that, I don't know, that's right, because the negative times negative became a positive. All right, so I'm on the right track here. So I have -11x equals positive 11, okay? And now my target, what am I trying to solve for? I'm trying to get x by itself, right? So I gotta get rid of that -11. Be careful here because we solve by doing the opposite operation, and that -11 is being multiplied. So opposite of that is to divide. So divide by -11 on both sides. So that means that x equals -1. There we go. I have solved for x, okay? But of course, I'm working a system of equations. So when you find one variable, you're only halfway done because I'm still missing y. So this is where step 3 comes in. I'll do that here to the side. Step 3, I'm gonna plug in, okay? I'm gonna plug in this number into one of my original equations. And again, you have two choices. You only have to plug it into one. Either way you do it, you'll get the same answer, but you only have to do it to one equation. So I'm just going to plug it back into my first equation just because everything here with the variable is positive, so that usually makes things easier. 8x plus y equals -16. And I always just bring over the original equation first, and then I substitute. So it's going to become 8 times. So I always use parentheses when I plug in. We already know that the value of x is -1, so I'm going to replace it. Plus y equals -16. That's going to become -8 plus y equals -16. Okay, now my target is to solve for y. Okay, and it's really important that you notice that there's an addition in between the -8 and the y. So -8 is not being multiplied. There's addition. So this is actually a constant. So you got to get rid of the -8 by doing the opposite, which is adding 8. I'm not dividing because it's not being multiplied. It's added. So be careful. So to get rid of -8, I've got to add 8. Which now I'm going to bring down that y. -16 plus 8, that's going to give me -8. And I have effectively found out the value of y. Okay, so now I know the value of my two variables, which means I am done and I have solved the system. Okay, again, what this answer means is that if I plug in -1 for x and -8 for y into both of my equations, it'll make both equations true. And you could check that by plugging it in, but just in the interest of time, I'm not going to do that. The only note I will make is if you are asked to write your answer as an ordered pair, then you would have to make sure you do x comma y, which would be -1 comma -8. And voila, you are done. So this one was, it was pretty straightforward. And notice that I was very intentional about what I eliminated. I eliminated y just because it looked easier. And in fact, it was. Okay, but if you're sitting there wondering, well, could I have eliminated x first instead? Okay, and the answer to your question is yes, absolutely. So I'm going to draw a little squiggly line, and I'm going to copy that problem over. So we had 8x plus y equals -16. X plus y equals -. Right? Here we go. So let's say that you don't realize that y is easier to eliminate, so you just want to eliminate x. And like I said, you can absolutely do that. But like I mentioned earlier, 8 times nothing will give you 3, and 3 times nothing will give you 8. So in order for you to eliminate x, you're going to have to create 0 pairs using the lowest common multiple, which we discussed on the first day that we taught you elimination. So let me bring those coefficients here. 8 and 3, okay? I'm not going to mess with I know it's a -3, but for the least common multiple, I don't really need to mess with the sign. I just need to know what the lowest number that they'll both go into. So I'm going to start listing them in order, right? 8. I know that 3 doesn't go into 8, so I need to keep going to the next multiple. 16. Does 3 go into 16? No, so keep going. 24. Does 3 to go into 24? And we know it does, right? So if you don't see it, you might keep listing more multiples, and you would have to do the same thing for 3. And essentially, once you get to the first one that they both share, then that's how you know you have the LCM. So again, I already know it's 24, but if you didn't, you would have to go through the process of listing. So 3, 6, 9, 12, 15, 18, 21. Notice how nothing is yet common with the multiples of 8 until, of course, I get to 24. So there's my magic number, if you will. So my least common multiple is 24. So that's what I'm looking for. So essentially, I want to turn this 8 into a 24, and I want to turn the 3 into a 24 also. Okay, and because I already have opposite signs, and I don't even have to bother with the sign. I can just leave the signs as they are. All right. So now, step 1. Change your equations or fix them so that you can have a 0 pair. And in this case, that's going to require me changing both of my equations or fixing both of my equations. So that has to be multiplied times 3 to give me the 24. And this one has to be multiplied times 8 to give me the 24. Oops, put the dot in the wrong place. Times 8. Okay. So let's see. 3 times 8x, that'll give me 24x plus 3y equals 3 times -16, that's going to give me -48. So I fixed the first equation. Now moving to the second equation. That's going to be -24x plus 8y equals -40. All right. So there we go. Now I have a 0 pair with x. So that allows me to move on to step 2, which is where I add my 2 equations. 24x plus a -24x, that's my 0 pair. So that cancels out. leaving me with 11y equals negative 48 plus a negative 40. That's going to be negative 88. Okay, and solving for y, right? That's my target. I got to get rid of that 11, which is being multiplied, so I'm going to divide by 11 on both sides, which means y equals negative 8. There we go. So if I go this route and I eliminate x, then of course that allows me to solve for y. So now I still have to figure out what x is. What's the value of x? So that's going to take me to step 3. So I'm going to plug in and solve for x. Step 3. And once again, I have a choice. I can either plug into the first equation or I can plug into the second equation. It doesn't really matter. And I'm just going to stick with the first equation just because the coefficients here are positive. 8x plus y equals negative 16. Be careful here because the negative 8 is going to be plugged in for y, not x. Okay, so be careful. The 8x, you leave it alone, plus, and I'm plugging in place of y, always use parentheses, equals negative 16. This right here is a little bit messy, so I'm going to clean it up. If you add a negative, it really is short for subtracting. So I can rewrite this as 8x minus 8 equals negative 16. So now it looks like a nice, clean two-step equation. I'm solving for x. Okay, so I'm going to eliminate the constant first, or eliminate what's added or subtracted first. So opposite of minus 8 is plus 8. Bring down 8x. That's going to give me negative 8. Once again, here's my target. That 8 is being multiplied, so therefore I will divide both sides by 8. Remember, you're doing the opposite operation. So that means that x equals negative 1. And there you go. And it just so happens that the answers we get doing it this way still match exactly the answers that I got earlier. Let me zoom out just a little bit so that you can kind of see it on one screen. So the moral of the story here is, regardless of where you start, which variable you start eliminating at the very beginning, if you do the math right, if you do your steps right, you'll get the same answer regardless, okay? But notice that eliminating y basically meant that I only needed to change one of the equations. I only had to fix one equation to give me a zero pair. Trying to eliminate x required me to find a least common multiple and then have to change both equations in order for me to create a zero pair with x. So it's still doable, but it's just a little bit more work and brain teaser. So the point we want to get you to is to be able to sort of recognize which way is the easiest way to go, because we obviously want you to do it the easiest way possible for you. Okay, and that might look a little bit different for everybody depending on what your individual strengths are. But generally speaking, there's usually one way that might be a little bit better than the other in terms of friendliness of the numbers and the simplicity of the math. Okay. Before I close, let me just go ahead and summarize what we did in this video. So, I went ahead and I reviewed with you the steps you learned, the general guidelines for solving a system by elimination. And I worked out an example for you both ways to address these two essential questions, which is, does it matter which variable you eliminate first, or does it matter how you start? And then does it matter what equation you plug into? I didn't really show this one just because I think you get the point that you always want to plug into the equation that looks easiest. But regardless of which equation you plug it into, you'll get the same answer if you do the math right. And I actually only worked out this example because example one, the level of difficulty, regardless of where you started, was really the same. So it wasn't really necessary for me to write it out and take up more of your time. But here's our conclusion. So it technically does not matter which variable you eliminate first, nor which of the two original equations you plug into. Okay? If you do the math right, you'll get the same answer. However, one way is often simpler and more straightforward. Okay, so we want you to try to go the easier route as much as possible. Okay, so that's all I have for today. Just remember that when you use your GPS to get somewhere, you have one destination, right? But your GPS will often give you at least 2 or 3 different options of different routes to take. And each one will have its pros and cons. But typically speaking, there's one better way, okay? All of them will still get you ultimately to your destination, but try to always take the best route, okay? All right, guys, thank you for tuning in. Let me know if you have any questions. Bye.